Differentiate y equals the quantity sine of theta over 1 plus cosine of theta and all of that squared. All right, so we got a quotient here, right? We got this trig function inside the parentheses, and we have this power here, right? So we have what we have called a composite function here. Okay, so we know at some point we're going to use a chain rule, but also, okay, I got trig function, just a quotient. I'm going to have to use a quotient rule here as well at some point, okay? All right, so what does a chain rule say? Okay, we know that if we have a composite function, right? Okay, so the derivative, right? The derivative of this, if y is equal to this, then y prime, or just a derivative, is going to be f prime, evaluated at the inner function times the derivative of the inner function here. Now, what do we have in this case? The outer function here, right? The outer function is, we'll just call that x squared, right? Okay, and the inner function usually is going to be what's inside the parentheses, right? So g of theta, I guess we should say, right? I mean, notation sort of important, right? I don't want to put g of x. Okay, it's sine of theta over 1 plus cosine of theta. Okay? So what is f prime of x? Well, the derivative of x squared is just 2x, right? Okay, here's where you got to be a little bit tricky. What is the derivative of the inner function, right? What is the derivative of this guy? And in this case, we have to use the quotient rule. Okay. Well, okay, wait a minute. What is the quotient rule, right? So the quotient rule says if we have something like f over g, right? I'm just going to use f and g. Okay, you can use a and b or u and v or whatever letters you want, right? But what is a derivative? Okay, so if y is that, then the derivative. Okay, now make sure you memorize this, right? And the order is very important, right? It's g times f prime minus f times g prime all over g squared. Okay. And once again, sorry about the notation here, right? It's not the same f and g here, right? We're talking about this guy. So what is it, basically what it's saying? We take the denominator, 1 plus cosine of theta, times the derivative of the numerator, right? In this case, the derivative of sine is cosine, okay, minus f, which in this case is just sine, times the derivative of the denominator. Derivative of 1 plus cosine is actually negative sine, okay? And all of that over 1 plus cosine of theta squared, okay? All right, now wait a minute, what happens here, right? So, like I separated this in two rows just because of space, right? But what do we got? Notice we have cosine of theta plus cosine squared of theta, right? I'm going to distribute that. This actually becomes a plus sine squared of theta all over 1 plus cosine theta squared. Hey, wait a minute. Cosine squared plus sine squared, that's just equal to 1. So in the numerator, I have cosine theta plus 1. On the denominator, I have 1 plus cosine theta squared. One of those actually cancels out, right? So we get 1 over 1 plus cosine of theta, right? And all of that work was just to find the derivative of the inner function here, okay? So if we go back to the original problem, right? This is we call this side work, right? Yeah. If we go back to the original problem, what is the derivative of this guy? Well, using the chain rule, or in this case, well, chain rule, right? But we want to find the derivative of the outer function, so 2 times x. But remember, we don't put an x here, right? We evaluate it at the inner function, so 2 times sine of theta over 1 plus cosine of theta. 2 minus 1 is just 1, right? So that's that, right? That's this guy right here, right? It's this right here. Times, though, right? Times what? Times g prime, which we actually found here, right? It's 1 over 1 plus cosine of theta. And in this case, this actually simplifies quite easily, right? We get 2 sine of theta. What do we get in the denominator? We get 1 plus cosine theta squared, right? And this is going to be the first derivative.